Hi everybody, my name is Lee Petty and I'm Commercial Director of Albion Valves UK Limited. Today we are going to look at one of Albion Valves UK Limited range of pilot assisted pressure reducing valves, the ART 6200. But before we do that, please make sure you subscribe to our YouTube page and also click the notification icon so you can automatically get notified of any new content from us. So as I said previously, today we're going to talk about Albion Valves UK Limited ART 6200 pilot assisted pressure reducing valve. We're going to look at covering several topics that I hope you will find useful. What pilot assisted pressure reducing valves do, the standards that a pilot assisted pressure reducing valve is tested to, the materials they are manufactured from, the specific applications where they can be used, any specific product approvals, and the applicable PED classification. So first up, what does Albion's ART 6200 pilot assisted pressure reducing valve do? An ART 6200 pressure reducing valve lowers high fluctuating incoming water pressure from the mains to a constant, safe and usable lower pressure for your home or building, thus protecting downstream fixtures, preventing pipe damage like bursts or water hammer, and saving water by preventing excessive flow. All this while maintaining steady downstream pressure despite upstream variations. All in all, a pretty clever piece of kit. We have now had a look at the general operating principles of PRVs and the primary reason why you may choose to use one. Now, let's have a look at the different materials that they may be made from. First of all, let's look at the main components and materials of pilot assisted pressure reducing valves, what they do and how they all work in unison. As you can see here visually, we have a valve body, a couple of gauges, each with an isolation valve feeding into them. One gauge shows the upstream pressure and one gauge shows the downstream pressure. Then we've got a couple of big silver bits on the top. These are a pilot valve which controls the downstream pressure and a needle valve. This controls the response speed of the main valve when the downstream pressure changes or fluctuates. There are also some other components that you can't see inside the valve, such as a valve seat. This holds the upstream pressure steady when the valve isn't in operation. A spring which is connected to the seat to hold it in place. There's also a particulate strainer around the back of the valve, and this filters any debris out of the valve body, which may go into the system. The valve body of an ART 6200 pressure reducing valve is the outer shell that houses the internal components, connects the valve to the pipeline by way of a flange connection, and handles the pressure of the fluid. It provides a secure enclosure and is the main structural part of the valve. Albion's range of ART 6200 pilot assisted pressure reducing valves are made from ductile iron bodies. We choose this type of material as it has good strength and flexibility characteristics. A pressure gauge, both upstream and downstream, measures and displays the internal pressure of liquids. This allows the user to monitor the system and ensure that it is working properly in accordance with the design parameters. A pilot valve on a pressure reducing valve acts as the brain, sensing the downstream pressure and controlling the larger main valve to maintain a steady, set pressure by modulating flow. It opens or closes small ports to add or release pressure from a chamber above the main valve's diaphragm, causing it to throttle or fully open or close. This setup allows for high flow capacity, accurate control and stability compared to simpler direct acting valves, making them ideal for more demanding industrial applications. A needle valve on a pressure reducing valve provides precise, fine adjustment of the downstream flow and pressure, acting like a dimmer switch for fluid, not just an on-off tap, allowing for gradual pressure drops, protection of delicate instruments and stable control where low flow rates and accuracy are crucial. Now for the bits you can't see. The valve seat and spring. In a pressure reducing valve, the seat is a critical surface against which the valve disc presses to either stop or allow fluid flow, acting as the main throttling mechanism to modulate high upstream pressure down to a consistent lower downstream pressure, balancing flow with the spring tension. When downstream demand drops, water pushes the disc against the seat, closing the valve. When demand rises, pressure drops, the spring lifts the disc off the seat, opening to let more water through, thus maintaining the set pressure. A strainer on a pressure reducing valve acts as a filter, catching grit, rust and debris in the incoming water line to protect the valve's sensitive internal components, such as the seat, disc and diaphragm, from damage, clogging or wear, thus ensuring the valve can maintain a constant lower downstream pressure and operate smoothly and reliably. Without it, debris can cause poor flow, pressure fluctuations or hold the valve open, making it fail to regulate the downstream pressure effectively. So how do you operate and set an ART 6200 pressure reducing valve? Isolation valves should always be fitted both upstream and downstream of a PRV. This allows for safe operation and maintenance of the valve. To set the valve, you need to first release the spring tension on the pressure reducing control valve by turning the adjustment screw anti-clockwise. After this, you slowly open the upstream isolation valve to allow controlled filling of the valve. You can then vent the air out of the pressure reducing valve by slightly loosening the bleed port at the top of the valve. Gradually turn the adjustment screw on the pressure reducing control valve to raise or set the downstream pressure. Then allow the valve and the system to stabilise. Observe both the inlet and the outlet pressure gauges and continue to adjust as needed, pausing approximately every 1 to 1.5 turns, which allows the valve to stabilise. Turning the adjustment screw clockwise raises the outlet pressure. Turning the adjustment screw anti-clockwise lowers the outlet pressure. When the desired downstream pressure is reached, tighten the lockout nut on the adjustment screw. To adjust the speed in which the valve reacts, you can use the needle valve. Turning it clockwise will result in the valve operating slower, and turning it counterclockwise will result in the valve operating faster. A pressure reducing valve should never be sized from pipe diameter alone. Good guidance is to reference a flow velocity of between 1 metre per second and 2 metres per second. This flow velocity can then be converted into metres cubed per hour, litres per second, litres per hour or gallons per minute by our internal technical team. Oversizing of a pressure reducing valve can cause significant operational and safety problems, primarily related to rapid cycling, which will cause a chatter, and this could lead to mechanical damage, reduced flow capacity and system instability. On the flip side, an undersized pressure reducing valve can also lead to several problems, most notably insufficient water pressure and flow during peak demand, as well as noise and potential damage to the plumbing system components due to increased water velocity, turbulence and water hammer. All Albion's range of pilot-assisted pressure reducing valves are tested to the same standards. This is BS EN 12266. This standard incorporates a few key tests. Firstly, a shell tightness test, and secondly, a seat tightness test. The purpose of the shell tightness test is to verify the leak tightness of the shell, including the operating mechanism against sealing pressure. The valve must be able to withstand 1.5 times maximum working pressure with no leakage present. For the seat tightness test, the purpose of this is to confirm the capability of the seat to conform to a specified leakage rate. The test pressure for this test is 1.1 times maximum working pressure with no leakage across the seat. Albion Valves UK Limited range of pilot-assisted pressure-reducing valves come with WRAS approval and so can be used on potable or drinking water systems. All polymers that come into contact with the water have a BS 6290 approval, so can be used on applications that are governed by Drinking Water Inspectorate. As with all valves within our product portfolio, Albion's range of pilot-assisted pressure-reducing valves conform to the requirements of the Pressure Equipment Directive, sometimes referred to as PED. Any certification that may be needed for Albion's range of pressure-reducing valves can be found on our website at www.albionvalvesuk.com or by contacting our in-house quality team directly on 01226 72 9900. That's all for today, but remember to ask for Albion for your valves, actuators and fitting requirements, available through your local independent distributor and suitable for a wide range of building services and industrial applications. Find product information including data sheets, IOMs, BIM components, approvals and general guidance at www.albionvalvesuk.com.